Okay, so we are going to go ahead and we're going to do some examples of distance and displacement. This worksheet comes from the physics classroom. This is a great resource if you want a little get more in depth, see a couple more examples, but helping you understand and see this here. So again, we're focusing just strictly on distance and displacement. It's really important that we understand distance and displacement before we move on. Especially because we have distance that we talked about is a scalar, which means it doesn't care about direction. And we have displacement, which is a vector, which does care. And we're going to see as we go on to our next topic of speed and velocity that those really come important of distinguishing between those two. So at times this might seem a little simple, but if you can get the distinction now, it's going to help a lot more when we get to those other topics here. So vectors versus scalars. In our last video, we talked about a scalar is just a magnitude, right? So if I tell you to go a mile, that's just the 1 mile. It's not telling you where to go, but that is kind of gives you that idea there, okay? So I'm going to, I don't need these text boxes here. Let me go ahead and grab this text box here. So distance, as we talked about, is a scalar. If I go 1 mile here. Now, if I tell you 1 mile to the east, that's going to be displacement, okay? Because now I care about that direction. And we haven't gone into speed, velocity, and acceleration yet. Now, that's kind of the 5 main things we're going to focus on for our second unit here of motion. But I'm going to help you out here in that speed is another scalar unit. We don't care about direction here. It's just how fast you're going. Well, velocity is going to be a vector here. So I'm going to put velocity here, and I'm going to put acceleration here. Hopefully you have this written down so that way we can come back and you can reference this if you need to at any point. So we go down here. A quantity that is ignorant of direction is referred to as ignorant, meaning it doesn't care about direction. Well, that's definitely going to be our scalar right here, our scalar quantity. So I'm going to write scalar right there. And a quality that is quantity, sorry, not quality, a quantity that is conscious of direction is referred to as a vector right there. All right, so let's go on now, and it talks a little bit about this distance displacement. Okay, that's what we talked about before. So it gives you this really good question here. An object can be moving for 10 seconds and still have 0 displacement. All right, well, can you move around in a certain type of way that at the end you're at 0 displacement? Well, what does that mean? If we maybe break that down and think about what that means, that might help us understand and make this a lot easier to answer. Displacement, again, is the final position minus the initial position, or how far have I gone from where I started? Well, can I move around and then end at this same spot where I started? Hopefully you can think of that, right? There's a bunch of different examples I can think of that. You know, if I walk 5 feet forward and then come back 5 feet, I'm starting and ending at the same spot. If I go in a circle, that's another really common example here of where I can end right where I started. So this is going to definitely be the case of true right here. Okay, an object can be moving for 10 seconds and still have 0 displacement. That is definitely true. So if true, then describe an example of such a motion. So if we can go ahead, I can say if I walk 5 feet forward and then 5 feet back in 10 seconds, right? It said in 10 seconds right here, so I'm going with that 10 seconds. Okay, so we know that because x final minus x initial, right? So my final would be 0 and my initial would be 0. All right. Well, let's say if I didn't even start at 0, right? If I started at 5, well, that would put me at 10 and then back at 5. We won't go too much in depth there, but that's the idea of what's going on here. Okay. I could have also said I'm going in a circle and I'm just ending back. That would have been fine too. But no, it's just we're ending where we started, is displacement. Question 6 here. Suppose that you run along 3 different paths from location A to B. Along each path, would your distance traveled be different than your displacement? So a couple things here. A and B are the same for all 3 paths. Okay, so we got to go on that assumption here. Is that A, the distance between A and B is the same here, that is right here, and right here. So then it's asking us, along which path would your distance traveled be different than your displacement? So again, what's my displacement? It's my final minus my initial. So maybe if I go ahead and draw my displacement right here, okay? So I'm just going to kind of draw a dotted line right here. Well, that's the difference right here between B and A, is this displacement. This is my distance. This is my path traveled. Well, are they the same here? No. My displacement is this, while my path traveled is this. They're two different. Okay, what about this one? Well, my displacement is still, it's going to be that quickest path between A and B. Okay, so that final position minus that initial position is my displacement. Well, this path is the same. So this distance is the same as displacement. And then this one right here, again, my displacement is just how far I am from the original. That would be that red dotted line right there. My path is different here. Okay, so the only time when distance and displacement, my displacement would be my red dotted line, my distance traveled would be my black line. The only time they're the same is when you move in a straight line. All right. So in cases, again, going back to this question, along which paths would your distance travel be different than your displacement? That'd be path 1 and path 3. All right, path 1 and path 3. I'm going to put in parentheses here. Only the same when the path is a straight line here. Okay. All right, so that's this first page done here. Let's go ahead and look at this one. Question 7. You run from your house to a friend's house that is 3 miles away, and then you walk home. So you are going to a friend's house, 3 miles here. You stay for a little while, and then you go back home. Okay? What distance did you travel? So I went 3 miles, and then I went another 3 miles. Remember, distance is equal to my total path. So my total path here should be just 6 miles. What was the displacement for the entire trip? Well, I started here, I went 3 miles, and then I came back to my initial spot. What do you think that should be? Take a second. What should that be? If you understand this, it should come to you really quick. All right? Turns out that one's just going to be 0 miles. Now, usually displacement, I would have a direction, but it's 0, so I don't need to have a direction here. Okay, so this one, question 8 and 9. Let me explain this to you. I would highly recommend pausing the video after I explain this and see if you can work this out on your own and then play it, and then I'll go over the answer. That's the best way to see if you're really understanding. Just listening to it is going to help kind of make it make sense, but to really make sure you got it, I really recommend after I explain this, pause this and try this. So what this is saying is you have a person walking along this path from A, going up here, over, and dip back down here to B. Okay. So think about this as like they're walking in a city, okay, and they can't go straight from A to B. Maybe there's a big construction going on right here, and maybe there's like a pond right here, and so they have to go this crazy path just to get to this location over here, okay? The first part is the person walks a distance of how many kilometers? So each of these little blocks right here represents 1 kilometer. Now notice if you're walking in the city, right, and you come to a corner, you got to walk the length of this block, and then you also have to walk the length of this block on this side, even though it's the same city block. So that would be considered 2 right here. So go ahead and count these up and see what's the total distance, right? And then see if you can figure out displacement. So I'm going to leave it, I'm going to just pause for a second. I want you to pause it and see if you can calculate those two. All right, hopefully you had some time. You went and see if you can calculate those. Let's do those together now. I'm going to go ahead and do the distance first. So distance, I'm just doing total path. So I got 1, 2, 3, 4, 5, 6, 7, 8. I turn the corner here, 9, 10, 11, 12, 13, 14, turn, 15, 16, turn, 17, 18, 19, turn, 20, 21, 22, turn, 23, 24, 25, 26, 27, 28, turn, 29, 30, 31. So the total distance that this person walks is 31 kilometers right there. Now displacement. Displacement is how far I am from where I started. Well, this is my displacement from here to here. How many is that? Well, that's 1, 2, 3. So that'd be 3 kilometers. But my answer is not B. Okay? Do not think your answer is B here. Because remember, displacement has a direction as well. So where am I from my initial spot? Our direction is from our initial. Well, I'm 3 kilometers east. Okay? Now that's going to be answer C right here. Because I am 3 kilometers east of where I started. All right, and that's my displacement here. Now, please don't put a direction with your distance, because what would even a direction mean, right? You first went north, then you went east, then you went south, then you went east, then you went south, then you went west, and then you went south again. A direction is meaningless with distance, but with displacement, it's really valuable because it tells us, well, where did I end up? Okay, what's my net change going on here? And that's 3 kilometers to the east at the end of the day. All right, last one here. Make sure we understand this. A cross-country skier moves from location A to B to C to D. Each leg of the back and forth motion takes 1 minute to complete. The total time is 3 minutes. So when you first look at this image, it might be a little confusing. Let me just explain this. This is one skier the whole time. The skier starts here at the 0 position, and then they go in 1 minute, they're going all the way to here. And then they go here, and then they go here. So this is just the path they go on one time. Now I'm going to get rid of that. Okay, but that's what the skier is doing. Okay, so in the first minute, they end up at B, then they move from B to C, and then C to D. So what is the distance of the skier? Well, distance is going to be equal to the total path. Okay, so let's look at these different segments. So for the first minute, the skier goes from 0 to 160 meters. Okay, it's meters right here. So I'm going to put in 160. But then from minute 1 to 2, they go from 160 to 40. Well, what is the distance between 160 and 140? Well, that's 120 meters right there. So I'm going to put 120. And then the last one, they go from 40 to 120 here. Well, that's going to be an extra 80. So I add all these up. I'm going to go ahead and add up 120 and 80 first. To me, that makes the most sense because I know 20 plus 80 is 100. So that's going to give me 200. 200 plus 160, that's 360 meters right here. The meters on the outside of this right here. So I don't lose my unit. Now remember, this is distance, so I don't care about direction. Well, now it's part B. What is the net displacement of the skier? So with displacement, we know is equal to x final minus x initial. So my x final, I don't care about everything that happens. I just care about where the skier ends. The skier ends at 120 meters. So I'm going to go ahead and put in right there 120 meters minus my initial position, which is 0. So I'm going to go ahead, and then my final is 120 meters, and then I need a direction. So this direction to here would be east. Now I can also say plus 120 meters. Because we said plus and minus are indications of directions. So I would say plus 120 meters, meaning to the right or east, or 120 meters east. Since I only have east and west, plus was the typical east right here. So it's up to you. You do have to make sure you indicate it. So either put the east or put the plus. You don't need to put both, but go ahead and you can indicate that. Well, now it says, well, what's the displacement from minute 1 to 2? So that's from position B to position C. Okay, well, I'm going to go to the same equation here. Displacement equals x final minus x initial. So my final, where did I end? Well, I ended at 40. So I come in here, my cursor back here. I end at 40 meters. Where did I start at? Well, I started at 160 meters. So what is my displacement here? 40 minus 160? Well, that's going to be negative 120 meters here. Now, I could leave it right there because negative indicating to the left, or I could write 120 meters west. Again, either one of those is okay because negative is indicating that, or I could just say 120 meters west. Last one. Well, what's the displacement from 2 to 3 right here? Okay. The displacement between these two, I'd use my same equation here, is equal to x final minus x initial. So my x final, that's going to be, for the last one, is 120. So I have 120 meters minus, and then it started at right here at 40 meters. Okay, so that's 40 meters right here. So 120 minus 40, that gives me 80 meters east, or I could just say plus 80 meters right there. Okay, and then that's my last one. Okay, so hopefully this is